Good morning, good afternoon, good evening to everyone, wherever you may be across the world. Thanks so much for joining us live here today for Serverless Office Hours, streaming on the Serverless Land YouTube channel and LinkedIn Live. Unfortunately, we're not an AWS Twitch channel today. Something about DynamoDB turning 10. What can you do? I suppose they've got to have a good party for that. So I'm Julian Wood. I'm a senior developer advocate for Serverless at AWS, and I'm super happy today to be joined by Norm Johanson. And Norm's a senior software dev engineer as part of the AWS SDKs and Tools part. And I think one of his sort of taglines is making .NET great on AWS. Now, Norm, you've been at AWS just under 12 years, which sounds incredible in sort of AWS/dog years. So Norm, welcome to Serverless Office Hours. How have you managed 11 years, 9 months or something like that?
It's just been a fun place to be. Yeah, it's been almost 12 years, all in just the same space. I've always loved, and even in previous jobs, is being the guy who makes the tools in the team, right? The developer tools guy. So, and now being the guy who makes the tools for AWS, it's always just been a joy. It's a lot of fun to try to wield the power of AWS into the .NET hands. So.
Have you always done .NET-ish kind of stuff, or have things sort of changed?
Well, unfortunately, I'm kind of old, so I do predate .NET by a few years. Back in the days, I actually did some C and Java. You know, Java was actually becoming the thing when I was in college. And so, yeah, my first job was when I moved out to the West Coast was actually making a plugin for Eclipse and Visual Studio 1.0 at the same time for UML modeling. And I was doing the Java side, but the .NET side looked really cool. And soon after, there was a startup company that was looking, and I said, I'll go join there. And I'd been doing .NET since the 1.0 days. So
wow, fantastic. So we have the right person to talk about. What we're going to be talking about today is .NET 6 on Lambda. But just before we do, let's have a quick look back over the past week. The last week's Serverless Office Hours show was Eric Johnson and Talia Nassi, both on my team, cool people, talking about Amazon DynamoDB. They're having their 12th birthday today. And last week was a really good introduction episode. Talia going through a whole bunch of cool information on getting started with DynamoDB and Lambda. So that's available for viewing on the Serverless Land YouTube channel. So just you head back and have a look. If you're wondering what's new in AWS Serverless over the past week, well, the highlight obviously has to be .NET 6 for Lambda, which Norm's going to cover in all its beautiful glory. There's also been some, over the past few weeks, a bit of sort of storage cool stuff, AWS backup for S3, and some accelerated integrity checking of requests. EFS also didn't want to miss out the party, so there's some Elastic File System replication, which will be super cool for your products, for your applications. AppSync as well keeps on coming up with some cool new things. We had a show earlier this year with Brice Pillay, who AppSync guru. So if you want to catch up on all things AppSync, go back and listen to this. And AppSync has now support for custom response headers, and Amplify also doing lots of cool stuff. And they've got the general availability of an authenticator UI library for Flutter. In terms of blog posts over the past week or so, of course, as I keep saying, the most important being .NET 6 for Lambda, which Norm wrote himself. Some other cool things that people have been writing about. Dan Fox and Roman Wojko talking about building TypeScript products with AWS SAM. So this is really cool. Obviously, TypeScript being a superset or part of the sort of JavaScript world. And this is a cool new functionality of SAM, which allows you to bundle in TypeScript. So if you're a TypeScript developer, we got your back and we can help you make it more easier to develop serverless applications. Amazon AppFlow is a cool tool for being able to connect different parts of your application together. So there was also a Serverless Office Hours and this blog post about using the custom connector SDK. If you're using step functions, which you really should be using step functions, it's an awesome service. And to be able to mock service integrations locally is super useful. And yeah, also a cool AWS virtual waiting room using a whole bunch of serverless services. If your website is being bombarded for stuff and you've got some back-end services that can't quite keep up, this virtual waiting room is a cool solution that you may be interested in looking at. So that's over the last week. AWS Lambda .NET 6. Norm, tell us about .NET 6 on Lambda. I know we've previously had .NET 2.1 and .NET 3.1. What can you tell us about .NET 6?
Yeah, actually, I was just counting out. This is our 5th managed runtime for .NET. We went all the way back to the 1.0 days. So yeah, we've been doing it all from the very beginning with AWS on .NET Core. .NET 6 is, I think one of the fun. I've been really excited about this one. Obviously, there's a lot of cool things in .NET 6, but this time I think we did a lot more enhancements to the way you can actually write .NET Lambda functions, trying to incorporate a lot more of the newer features in the language.
Oh, cool. Yeah, I was having a chat with one of our top product managers before .NET had actually come out, and he was saying, well, we did a good job with .NET beforehand, but we've done a great job with .NET this time. And he's actually someone who's worked in the .NET world for a while. So yeah, this isn't sort of any just quick sort of version upgrade, right click, install upgrade.
Right.
I think a lot of work under the scenes has gone from your team as well to be able to provide a really good runtime for .NET.
Yeah, but I mean, to be clear though, you can, if you're moving from 3.1 to 6.0, it can be a matter of just changing your target frameworks and stuff like that.
True. I suppose I didn't mean your functions, but what we've done on the back end, it wasn't just uninstall .NET 5 and install .NET 6 and we call it a day. So
yeah, it's never quite that simple that just install the latest version of .NET and Lambda and there we go. It is. We do a lot of things go into place in creating the managed runtimes. So yeah, I thought first I'd show you a little bit how you can get started with .NET, because some of the people who on the server that are mine have tried .NET. Let me see my screen being shared here, Julian.
I can add it on. There we go.
All right. So obviously with Lambda, we've got multiple ways that you can use build your Lambda functions, all depending on how you like to do things. You can do things through Visual Studio. We also integrate with the .NET CLI and, of course, with SAM CLI as well. Being on the .NET side, and I've contributed a lot to the Visual Studio and the .NET CLI, those are the ones I'm going to mostly talk about today.
Well, this is cool because you're actually working the AWS SDKs and Tools team.
Right.
You're sort of at that perfect intersection of sorting out the two things.
Yeah. So yeah, if you have the AWS Scope for Visual Studio installed into 2022, that's where you have to have for .NET 6. .NET 6 is only available in that one. If you create new projects, and here I think I've already got the filtering set up to filter to C# and AWS, but we've got these already project templates built in there. We kind of break them into two different categories. We've got what we call our Lambda projects, which is where you want to usually create a single function and then deploy that straight to the service. And then there's the serverless application, which is kind of a fancy way of saying you want to deploy to CloudFormation. So you're going to create maybe a collection of functions and deploy there. So it's kind of like writing a SAM template and deploying it through there. We have these for both C# and F#. So we want to support both those languages out there. F# has some cool new features in F# 6 to make it even easier for writing .NET functions. Particularly, F# has a new task computation module. I can't actually remember what they call them. Sorry, just bled my ignorance there. But it made it easier to write asynchronous programming in F# that worked really well with the Lambda runtime as well. So it's a lot easier to write F# Lambda functions, just due to the nature of the language improvements done there. So let's say here, let's go create a C# Lambda function project here. Looks like I'm on project number 55. That's how many dummy projects I've created. So then we have a few blueprints inside Visual Studio. Here's the dead simple. I just give me a scratch pad to start writing everything I want to do. A bunch of sort of simple ones, setting up the events. We do support also container-based. So .NET 6, we released a container. So you can do those types of deployments as well, and a few sort of use case ones as well. And our custom runtimes, this is always a feature we've had to allow customers who want to use a version of .NET that's currently not a managed runtime. Basically, it helps you deploy your Lambda function as a self-contained .NET application. It's not particularly useful right now because right now .NET 6 is out and that's the tip of .NET. So if, in that case, you really just want to use the managed runtime. I think right now it's most useful if anyone who wants to try the .NET 7 previews. Like that's a way you could do that. You could create a project using that and easily target 7 preview and test it out.
Okay, so people mainly using the custom runtime to sort of get ahead of the game. They're not particular nuances that some people may be using custom runtimes to have, different functionality with .NET 6 or something.
Yeah, it is really,
Okay.
it is, like I said, it's people who gets excited because generally we only support the LCS versions of .NET. So it's like, I want to do that. Or like, .NET came out in November, and I know a lot of people had been like, I want to do .NET 6 now. So they were using custom runtimes there.
Cool.
So I thought, in the spirit of DynaDB's 10-year anniversary, let's create the Lambda function for DynaDB. Let's just take a look at what we did there.
And yeah, but I forgot to say, silly me, we're live, serverless office hours. Please send any questions you do have in the chat. We've got Norm, the expert, to answer any of your questions. And if they're not about .NET or they're other serverless kind of things, chime in and let us know. Also, let us know where you're coming from. We'd love knowing where people are watching and viewing from. And tell us any feedback you got is super appreciated. And of course, questions for .NET as well.
Definitely, love to hear what people have to say, and it's always great to hear what people are doing and building with our stuff. So for Lambda functions, and like I said, for the most part, things haven't changed a lot. If you don't want them to do this, looks pretty similar. I think in the templates, the main code change we did, .NET 6 added the idea of having file scope namespaces. So I updated all the templates to be that way, so we can get rid of one level of indentation. But pretty similar what we have here, right? We get our DynaDB object and loop through our stuff and do some logic here. This is not too different than what we've been seeing in 3.1. But I think I wanted to point out the project file. We did make some changes in the project file for the default settings in our blueprints. Again, trying to mostly light up some of the features in .NET 6. So .NET 6 added that implicitly using. That's why we don't have to have all those system using statements anymore. We can kind of get rid of a lot of that boilerplate in there. We wanted to turn on nullability on there for everybody. But really, this is the one I want everyone to go home and learn about. It's particularly important if you're migrating your project effects. So this is the ready to run feature, which has been around in .NET for quite a few releases. But it's been a little hard to use in the past. So what ready to run is it basically at publish time, it will convert your machine agnostic, the IL that you get compiled to, into the machine instruction symbol that basically it pre-jits your assemblies. So this can really reduce your cold start times. So you really want to always have this on when doing publishing. In the previous versions of .NET Core, though, in order to do this, you actually had to publish on Linux in order to take advantage. So I couldn't turn it on in Windows and deploy it. The .NET compiler wouldn't allow that. In .NET 6, they enabled cross-compilation. So now, no matter if I'm on Windows or Mac or whatever, I can turn this on, and the .NET compiler will do all that pre-jitting for me to Linux. So that
that is super cool. Yeah, because I mean, this is the sort of eternal conundrum with languages that are super clever, like .NET, when you just import things and it's already going to discover what they are and able to do all its in time compiling. But with Lambda as an execution environment comes up, that's going to take time. If you can do anything in advance to be able to speed that up, and this is great because it's actually part of a binary. Other languages like Python and Node, if you've got to do any speeding up, that's got to happen during your cold start process. You haven't got the concept of packaging stuff in terms of a binary. So yeah, I think this is fantastic. This will really, I'm sure, make a huge performance.
It does help, and it's super easy. Like I said, and so all of the blueprints for .NET 6 got updated to always have this on. So definitely, but as you're migrating, make sure to add that in there in your CS push files so you can take advantage of it.
Are there any considerations where people may not do that, or is that just a default that you can't see something see a reason you wouldn't do that?
I don't think that. I mean, I think that the normal reason why you would maybe not do that is if you don't know, in a pure .NET sense, maybe you don't know where you're going to run it. I'm going to publish this, but maybe I'm going to run it on a Mac and Windows and Linux. In that case, you can't pre-jit it. In our case, we know Lambda's running on Linux. So there's not really any particular reason ever to run that one. So.
Well, thank you, Martin, also for joining us. Thanks, Martin. And yeah, good reminder that you need to turn on ready to run on for builds done on Windows. Thank you, Martin. Yeah,
Martin is he's always a good contributor to the community. He's always out there helping out our repo. So
perfect. Thanks,
Martin goes way back in all this stuff. So
appreciate it, Martin.
So yeah, this is like I said, this has been the normal way of writing Lambda functions for quite a while. In newer versions of C#, C# 9 in particular 10, they've been doing a lot of pushing for what they call top level statements, like get rid of all of this sort of boilerplate sort of code. And we wanted to help support that in .NET 6. So, and we did. So if I create one of those projects, so we say Lambda project, and I want to say you have got this empty top level one. So if we compare what that looks like, so here you can see all this sort of normal boilerplate stuff goes away. We basically just define this is the handler that we want to be called. And in a top level statement, you actually have to start up the Lambda runtime client. So we start that up passing in the handler in there. So because the difference here is in our project 55 here, our normal one, this is a class library. And when we deploy that class library to Lambda, there's code in the manage runtime that basically starts up and loads our class library. And using our function handler string, which is the Lambda argument to say, this guy here, it basically uses that to find the piece of code in that class library and calls that all the time. So because this is listing the name of the assembly, the name of the type, and the function handler, that method, and so we know to call it. So you can imagine essentially we're using some reflection to find that method to know how to call that. But in the case of the top level statements, and now top level statements are sort of a glorified compiler sugar that might offend some people over at the .NET team, where basically all of the code in this top level area gets essentially added inside a generated main method. So there's a main method that gets executed for this one. And so in that case, your code is what's being executed when the Lambda runtime starts. And that's why you have to be the one that starts up the Lambda runtime client, because it's not our normal layer that we have initially.
So does that also give you more control of what you start in the cold start process? Does it work like that way, or have I got my understanding incorrect?
I think you have as much control, but it's slightly different, right? Like anything I do up outside before I run this code is the cold start time, right? All that gets kicked off for me. Versus in the normal class library way, like the stuff you put in the constructor, stuff like that is there. So this is probably, like I said, might make it a bit more idiomatic of like, I need to do a lot of initialization stuff right here, not just dump a bunch in the constructor there. So the way you tell us though, that when you're deploying something and you want to deploy this as what I call an executable assembly, that function handler string changes a little bit. Instead of taking in those three parts like we normally do here, assembly and type name and method name, now when we do a deployment, we just specify the assembly name. And basically our computer, our logic on the manage runtime says, oh, I see there's only one token in the function handler string. This must be an executable assembly. And we just go and execute it, assuming that you're starting up the runtime client for us. This did bring some interesting challenges for us on some of our testing stories. So in the .NET space, we've always had, or have had for several years, what we call the .NET mock Lambda test tool. I was not the one who named that one, so don't blame me for that one. I just wrote it. I didn't name it. That's my excuse. But basically what this tool does is, like, if I'm in Visual Studio, like here's this, our original function, I can just go and set a breakpoint in here, and I can push F5, and that'll automatically launch our test tool here in a second, and it probably is going to open it in the wrong window here. There we go. Yep, wrong window. Of course, right? So here we go. This is our test tool that we have, where now I can go in and say...
Can we just zoom in a bit on that, Norm?
Sure. How's that look?
Yeah, that's better.
So yeah, I can go in and I can say I want to run, let's say I think I set a DynaDB request. So basically kind of paste in what I think the JSON object looks like for this event. I can execute that, and that stops right in our code. So this gave us like that very quick, I want to just do F5 debugging right away in there and sort of test my code, how it works with the JSON events that come through. This tool works out pretty well for like testing your application logic, because the way it works is essentially in Visual Studio right now, the debugger is attached to the test tool. And the test tool is loaded up my code, my class library inside of that to go and start executing it. And so now when I set the debugger, or set the breakpoints in there, it stops on there. So it's good for testing application logic, but keep in mind, we are basically, I'm running this on Windows, right? So this is not going to test sort of platform specific issues that you might have.
Yeah, so it's sort of just your business logic kind of thing, and anything that you can do literally within the Lambda function that's fairly, app specific. Is that available just with Visual Studio 2022, also Visual Studio Code, or?
So the tool is just an actual, it's a .NET CLI tool. Like if you go into if I go .NET lists, tool lists, and see here, I've got the tool installed. So any IDE can actually use it. And on our GitHub repo, we've got instructions on how you can use the tool for Rider and VS Code and Visual Studio for Mac. So but with Visual Studio, the AWS toolkit for Visual Studio takes care of automatically setting it up. Like once I create the project, we take care of writing this properties, the launch settings that get it all set up for you. So, but so that part's been around for a while. But what I do want to also point out is like, because now we support executable assemblies, that made our test tool a bit more complicated, because no longer am I a class library. Now I'm an actual executable that's automatically going to try to hit that Lambda endpoint to go and find events to process. So what we did is now, if I go and launch this tool directly, I have to just save myself some dumb typing. So this is a .NET CLI tool I got in. If I run it directly, so in the 6th version, we added this new page, this executable assembly page. What we're doing on this page is essentially simulating the Lambda runtime API. So when you deploy a Lambda function and you have that Lambda runtime client, it's making HTTP calls to the Lambda service to go get the next event to process. So that's now what this page is. We basically have set up a local host version of this endpoint for us. So I can go, let's see, I think my function here is just taking in a string here. So let's say I want to have this breakup. I want to test this guy. I can say, I'm going to queue an event. Hello, world. So I can go and queue up some events, and it's waiting for now some Lambda function locally to go attach and start processing those events. So now I can configure in my Visual Studio, set this environment variable to point to there, and it'll actually go and start pulling those events. So I'm going to go say properties, and let's go to debug. And so, we're going to configure our debug sessions to set that environment variable to go to localhost 5050, which is what we just saw on the screen. Now that I've done that and the tool is just running, if I want to debugging, all I gotta do is just push F5, and I'll start, hitting, getting the request from there. What did I do wrong? Apparently, I mistyped it. All right. So apparently, what did I do? I mistyped hello world. Oh, did I put a colon on there at the end? See, now we've tested how we got errors when you have a bad JSON document. So here we can say hello correctly again with the actual parentheses. And we can see now we can do the testing right from there. See, we got that in there. And so we get our responses there. So it's again help us get sort of a local test environment. We can see our failures here. If I want to rerun this case again, I can go run it again, which has already run the invocation. So if you want to set up sort of that local test environment, this can be really helpful for you.
Yeah, that is super amazing. Because actually I'm working on another bit of a project on the side to which I'm doing some interaction with a Lambda runtime API, and this could be super useful, in fact, for any language, because it's running a local Lambda mock endpoint. Of
That
course,
is true.
it's got a connector error kind of things, but the actual backend pretending to be Lambda could be very useful.
Yeah. I mean, obviously, I wrote this in the intentions for .NET developers, but yeah, this is just the standard Lambda endpoint. As long as you set that environment variable, send that over there. So. Yeah, so that's definitely new ways to write Lambda functions. Like I said, we wanted to make sure that the old ways still work, but we wanted to take advantage of the new ways of writing .NET code using top-level statements. And there's obviously the new ways to do testing as well to support those cases, which has also been useful. Again, right now, custom runtimes isn't terribly useful because .NET 6 is the tip, but we've always had the request that customers who write Lambda functions using the custom runtimes couldn't use the mock test tool because it's an executable. So now, when you do use custom runtimes, when you want to test your 7.0 functions, you can use what we just used there, right? It's the same technology. Like you said, you can use it for Python and TypeScript. We can also use this for custom runtimes. Anything that's just basically running an executable, Xing there works that way. All right, so that's the new programming model and the testing. Another big change that we did for .NET 6 was logging. We improved the logging in here. So if we look at this example here, we've always had logging on the context logger. We've had the log and log line methods since the original .NET Lambda runtime. But we've had a lot of requests over the years of like, I want to have log leveling and I want more information being deployed out there. Actually, let me deploy this Lambda function so we can see what this looks like. That'll give me some context here. So right-clicking on the toolkit, and I'm just going to go and deploy this. And by the way, I should point out this works in both x86 and ARM, so you can try either one of those platforms.
Yeah, I was going to ask about that for .NET if it was that simple. Yeah, use Graviton 2 in ARM, save 34% price performance difference. Can't go wrong with that.
Yep. So yeah, this function, I think, this function didn't take any events. So if I just go ahead and run this one, we can see now the output here is I can actually see all the log levels for the error messages or the messages going out. And this is also a highly requested feature we've had over the years is I wanted the request ID added into there because people were sending out their log messages to Datadog and other sort of logging systems, and they wanted a way to track that back. So we added in the date and the logging in there for us.
Okay, so yeah, it's a bit small on the screen, but I suppose we don't necessarily have to blow it up if you can't. But so date and time, request ID, and then the log level. Is that what that's showing?
Yep. Yeah. Sorry, the toolkit here is not great at expanding fonts.
That's okay.
But yeah. And so yeah, if you see though in squinting your eyes, you only see the info in higher levels, even though I did have trace and debug. So by default, our logging mechanisms only actually write messages at the info level and sort of higher, as well as the console messages, which are considered info messages, and console error lanes are considered error messages. So if you want to adjust the logging level, like I want to put debug and trace in there, all you have to do is set an environment variable. I'm going to go to my cheat sheet here. So I set this environment variable. Go and Set that there. Set the level to trace. Apply those changes. Now, if I go and run my function here, see, it's creating the function. Stalling. There we go. Now we get the extra messages. We get trace and debug in there as well, which weren't in there before. So this is a good way of, like, by default, you can add a lot more diagnostics, messages in your system that you don't necessarily want to have me print out every time. You only want to print out if, like, hey, I got it, something's going wrong and I just need to get more information. I can easily toggle these levels in and out by setting these environment variables for us.
And so you can set those in environment variables as part of the Lambda config, but also within a Lambda function, can you just set that environment variable sort of on the fly for, within the same invocation that would then start to do debug? So, potentially if you're trapping an error message, some people may want to turn on
right
debug.
Now, we don't have that. You have to set it at that point, because we're only looking at that config environment. I think we're only looking at it at the beginning. So we do know some customers, they do prefer the old style, where we basically didn't put any, logging message was freeform. They were doing that particularly because they were sending, like, JSON documents that they wanted to be, parsed through. So it is you can turn this off. If you prefer the old format, what you do is, again, you use this environment, the log format environment variable. We'll add that. You just set it to unformatted, which is essentially the old format, if you want to call unformatted the format. And that'll basically make like it used to be. So again, if you don't want any changing behavior, set that environment variable. And now if we go and run that, this is what it looks like always before, where there's no levels or request IDs or timestamps, stuff like that. That's very useful for customers that were, like I said, they had their own system that they've already designed over the years, and we didn't want to get in their way. All right.
So I suppose, if you also shipping off your log somewhere else and you're doing some log analytics or some parsing or Splunk Datadog, even CloudWatch Insights maybe, and you have existing queries, this is an easy way to at least migrate over to .NET 6 without having to change those queries, and then in time you can move over to a newer log format.
Yep.
Cool.
Another feature that was part of C# that we wanted to, or .NET that we wanted to take advantage of was, we do a lot of JSON parsing in Lambda functions, right? Because the events that come into us from Lambda, they're JSON objects, right? So, and we always use this. Well, we haven't. We've been using since 3.1 by default the built-in JSON library, system text JSON. Now in .NET 6, the .NET team added support, what they call for source generator support. That allows compile time to generate the code that it takes to do the JSON parsing without reflection. And that's one of those, again, those tricks you can use to reduce your cold start time. So we made some support into our programming model to be able to include that. So let's show you what that looks like here. So here's my generator example. Here is my Lambda function, which is, your hello world of the API gateway request, right? So, we take an API gateway request and we send back the response. So let me just deploy this out right now so you can see what our base case is here. So. All right, I'm going to deploy this out.
So is this just not Visual Studio Code, but just a Visual Studio plugin as part of your SDK team that just, because this is super slick, I must say, the way you're able to just deploy the functions directly from VS Code, do your editing, do your testing and everything without leaving your IDE, that's pretty cool.
Yep, yeah, we've had this for the AWS Visual Studio. You can download it from the marketplace. There is a separate extension, although it's mostly the same code, but a separate extension for 2022, VS 2022 versus the 2019. But definitely, if you're a Visual Studio developer, this can help sort of that just sort of like learning and playing around and try to understand how to test things out experience.
Is this just then creating and testing Lambda function code, or when you have this example here where you have an API gateway attached, can you add the API gateway as an event and is using some sort of CloudFormation thing in the background, or we're just talking about Lambda function code?
So like I said in the beginning, we sort of have two different ways we can deploy. We can deploy straight to the Lambda service, is which example here, or if you create the serverless application project templates, those go through CloudFormation.
Okay, yeah.
And that's normally how I would have done this demo, but I didn't really. In this demo, I just want to talk about serialization, so I didn't want to do the extra API gateway part. So yeah, here is I'm going to show if we run this request right here. Taking in, this is the example of an API request, and don't worry about the body here. It's just example of an API gateway request. If we run that here, that cold start here was about 500 milliseconds here for that cold start. So this is using our default JSON serializer. So this is coming from system text JSON. So we actually support two packages. If you're a Newtonsoft user, there is a Newtonsoft based serializer, but I would highly recommend you actually use the system text JSON one. It is much faster, particularly for cold starts. Newtonsoft one is pretty slow for cold starts. But this default one, what it's doing is it's using the usual sort of reflection-based serialization. So we can change this code to actually use that source generator support that I talked about, where we actually will, at compile time, generate all of the code that's required to do that. Now, to do that, I'm going to go to my cheat sheet here real quick, and you create what's called a serialization context. So it's a class that extends from JSON serialization context, which comes from the serialization namespace. It's a partial class because when I compile, it will actually go and generate all the serialization information needed for the listed types up here. So this is my inputs and outputs here. So we're going to get all of that done at compile time for us. So if I go, just to give you an example what I'm really talking about here, let's just look at the DLL, right? So here I've compiled this into this guy here, and I've got the JetBrains.peak, right? This is decompiling it. If I actually look inside that assembly, we can see it actually has generated all this type information for this. So I don't need any reflection to actually do the JSON serialization.
We're sort of going to have to believe you because it's a bit small, but I think we get the idea.
Yeah. So, yeah, but no, there's a bunch of stuff in there that wasn't there that I didn't code.
Yeah.
So now to tell Lambda to use that, I'm going to not use the default serialization. I'm going to say use source generator, and I got to pass in our context object here. So I've changed this attribute, which is usually this Lambda serializer, which is what we use to indicate to the Lambda runtime what is the serializer to use this class using this context object to handle all of our serialization. So now if I deploy this guy, going. See, all right, here we go. So let's see if I'm making stuff up here. So here are our cold starts here, 500 milliseconds. I run this again, and it went down to 411. So
oh wow, I mean that's literally
I've seen
10%.
It actually better, but yeah, this is I think she gets 20%, right? 500 to 400. So just doing that, it's a small change. I mean, obviously, if you're doing a lot more in your Lambda functions, the delta is going to be a lot. It's going to be different. But overall, it's a pretty small change you can do to your Lambda functions to get a little bit more performance improvements in your cold starts.
I'm amazed. Just for a serialization library, that's pretty impressive.
Yeah. So yeah, definitely check that out. You do need to create this class in there, but once you do that and plug it in there, that's all you have to do. Now you're just taking advantage of it. So you get basically more bang for your buck when like this request object is pretty complicated. If it's a very simple one, you probably won't notice as much. But
Yeah.
Definitely, when migrating, try it out. And I don't think there's any con for doing this. There's only a plus for it. So let's see how we doing here. So the other thing I wanted to talk about here, I got two more things I'd like to try to talk about. So in our Lambda.NET world, we've always had support for running ASP.NET Core applications as a Lambda function. In fact, if I go back to my Scratchpad one here, right? If I go and say I want to create a new project. So in here, I'll say I want to create a serverless application. So that we've got in the serverless, we've got this sort of empty one space. We've got a WebSockets one. Step functions, like you said, step functions are cool. But we also have these ones that are using ASP.NET Core as well. So we basically allow you to run ASP.NET Core as a Lambda function, which works out pretty well in the .NET space. I know a few other languages have this sort of bridge library that they use between their popular web framework. For .NET, I think it works particularly well because in .NET, all of the constructs of ASP.NET Core are built into the language, essentially. So all of the ASP.NET bits are actually inside the managed runtime. So you're not having to include any large packages to deploy an ASP.NET Core Lambda function out there. Now, like we saw in the top level statements, the ASP.NET Core team had been doing a lot of work in C# or .NET 6 to support minimal APIs. This is essentially the top level statement version of that. So we added support for that since we've got top level support. And if we take a look at that, and I'm going to to save me some time, I'm going to deploy this first. And while this is deploying, we can talk about it. So this is going to deploy to CloudFormation. So that way our screen changes here, right? So since we're doing CloudFormation, we just have to put in a stack name and an S3 bucket of where we want to store our temporary artifacts here. So I'm just going to let that go here while that's happening. And I'll take a drink of water. There we go. Going, uploading S3, and now we're kicking in CloudFormation. So we're not deploying straight to the service like we saw in all the previous demos. So this is a case where, we're launching our CloudFormation stack up. Our CloudFormation template is pretty simple here. We've got one Lambda function, which is setting up the API requests, the API gateway stuff, and we're just essentially doing wildcards into our thing. But obviously, since it's CloudFormation, I can add all the other resources I might need if I need to set up S3 buckets and queues and all those other things in here. But back to the point of this talk is, now that we support top-level statements, we can write Lambda functions using minimal APIs. So here is a whole ASP.NET Core application written and to be supported for Lambda. Now, what I think is really cool about it is the actual only Lambda specific code in here is this one line right here. Everything else is standard ASP.NET Core code. I just added this one line here, which actually, if I was to push F5, it does nothing. I can just run this still locally as a normal ASP.NET Core application. It doesn't interfere with how my application is running. So that's one of the reasons why people like the ASP.NET Core approach is they know how to actually write their ASP.NET Core applications and debug it. I'm not sure. I think this went to some other window. I'm not going to worry about why that didn't come up. But yeah, they know how to write ASP.NET Core applications. They've got all their plugins, and they can do all that work. And this code here will do nothing if you're running locally. But when it detects that you're running actually inside Lambda, that's when it kicks in. And what it does is it basically swaps out Kestrel. Kestrel is our .NET web server. It takes that out, and it basically plugs in our NuGet package, Amazon Lambda ASP.NET Core server, as the actual web server. So that sort of mocks out the web server, which really does the translation between what requests and responses are supposed to look like from Lambda's point of view to what ASP.NET Core is supposed to be. So is
this running a web server within the Lambda function, which is able to still take advantage of the sort of freeze thaw process as invokes come in, and run your ASP.NET Core?
It makes it look like that's what it's doing, but there's no actual web server going on. Like I said, this library here is essentially mocking out the web servers. So it's all running in the same process, the same Lambda process. It's got that. It takes in the Lambda event, translates that JSON document into an ASP.NET Core request, and does the reverse on the output, changing to the response. So it doesn't actually add a lot of extra overhead for spinning up another web server or anything like that. So it doesn't do a whole lot, as long as you keep your ASP.NET Core is sort of a reasonable size. Like, this is not a statement to say make your giant monolithic ASP.NET Core application and run as a Lambda function. If you do that, you will have cold start issues. But if you make a small ASP.NET Core application using the things your cold starts can be quite reasonable for this one.
Yeah. Wow.
This also takes care of, since we're doing top level statements, and this is like an executable assembly, like we talked in that earlier demo. This library also takes care of starting up the Amazon Lambda runtime client as well. So all that is taken care of for you. You just deploy it to there. So if I was to go back over to my cloud, and I can see here's my Lambda function deployed here, and there it goes. This is an ASP.NET Core Lambda function using the plays deployed out to Lambda with just like that. So.
Wow, that is super slick and minimal. It is a minimal. It did say minimal. You're right about that.
We kept. You might have saw in the project wizard, I kept both styles of the project templates. One is the older, the previous style of using program and startup, and minimal API. So definitely you can choose which style you want. I'm quite curious to know which people will prefer. But yeah, definitely. Okay, the last thing I wanted to try to squeeze in here to talk about is, like, so far we kind of have two different programming models, right? We've got that sort of low-level programming model for Lambda where you take an event and then do all the work from there, which is like every Lambda runtime out there is like that, right? And then we've got this ASP.NET Core layer we can run on top of that to do that. So we've been working on a new library that's sort of trying to be somewhere in the middle of that, where we're getting a lot of the convenience of writing things in an ASP.NET Core sort of way, but maybe not have quite as much overhead of that. So what I mean by that is my last demo here. So, like, here we go. This is, again, let me make some space here. Here is, this is like your normal way, like, of writing an API gateway Lambda function, right? This is kind of a dumb method here. It's my calculator that's going to do an add method, pulling in the integers from the resource path, adding those up, and putting them there, right? So there's a lot of boilerplate code in here, and you got to do all of the stuff coming from here. What we'd really like to do as .NET devs is write something more like public int add and x and y, right? That's really what we want to write. That's all that's the simple thing we want to do. So with our new annotations library, we can actually do that by adding a few attributes onto our code. So I can now just say this is a Lambda function. And I can also say that this is an HTTP API, going to be a GET, and that the path is going to be add that. And I can just compile that there. And this is now a Lambda function. Because I have my serverless template file, my CloudFormation template. By compiling that, that actually updated my template to now have my new function added to it right there. So this helps us to stay in context, stay in our code, and not have to go back and forth between our CloudFormation template and our code. And now if you notice, we've got this sort of weird name. Where did this name? This is sort of using the same technology that we saw the .NET team use with the JSON parsing. We're using a source generator to generate all of the code in between that Lambda low-level programming model to getting us something like this. So that helps us write something a bit more idiomatic. Another thing it helps us is we've had a common request for, how do I include like the .NET dependency injection? Like it doesn't really fit very well with sort of our classes, structures, and stuff like that. So, but now we can have that concept of having a startup class. So if anyone has written ASP.NET Cores, they're probably used to seeing a startup class with a configure services method. I can now use that to define my dependency injection in there. So for example, let's go back into my cheat sheet here, and I'm going to create a calculator service class. For time's sake, I'm just going to throw this at the bottom here. Bear with me there. Pretend I created another file and I didn't violate everyone's coding.
No, of course, I wasn't watching.
Okay. So yeah, I've got a service over here. Now I want to go and actually register that, right? So I can say service add singleton, we'll say calculator service. Right. So this is the standard way then of how you would set up a dependency injection. And to tell our library that we want to use this, we would say Lambda. We add the attribute to say this is our startup class. So now our source generators are going to know, oh, I see that this assembly's got a startup class. This is how we're going to set up the dependency injection. It's going to take care of setting up all that boilerplate for us. Now, in my class over here, I can use the constructor injection and just say calculator service here. And now we can start using that. Right. So now we're able to, and obviously this is a contrived example, but you can see how you can start injecting in your services in ways that people are used to with the dependency injection. Well, they've been doing it in all their other applications. There's sort of two ways. There are two ways you can inject things. You can do it through the constructor, or you can also do it on the actual method. I can say from services. Oh, come on. I can do it either way, how I want to get it injected. The subtle difference between the two is if I inject it in here, in .NET, the dependency injection has the concept of scope, like when does this resource get created? Here it's going to be created for the lifetime of this Lambda compute environment. In this case here, it'll be created per invocation. Like if I've got a service that every time I want to come in through here, I want a new instance of this service, I would add it this way here.
Thanks. Rahul just has a question. This is great. Thanks, Rahul, for joining us today. Does Lambda create a new instance of the class for each invocation, or does it reuse the same instance through its lifetime?
It uses the same invocation for each one. So, yeah, and so
that makes sense.
Yeah, we can imagine I would add all the other add, subtract, defaults, but I'm going to just show you, and I think this will help answer that question. We're going to go disassemble that one again. I think I'll be able to make the code bigger this time in the tool. Let's hope. So if I look at where did go? So it's a little freaking out on me over here. So over here, this is the generated class. I'm going to decompile it here. I think I can make that bigger once it does that. There we go. How's that?
That looks good.
So yeah, this is the generated class that we created for you. And you can see it took care of creating all of the startup classes, configuring the services, this is where I said we created a scope for each invocation of there, and we go and do all of that marshaling for you from the request object into there. So all of that sort of boilerplate code is taken care of for you by using this list library. So this library, though, I should point out, like, this is the library we have in preview out there. So this is, I think we're, at .5 or what early versions of this library. Sorry, I'm kind of flipping all over the place. And we'd really like to get people's feedback on this one, because we're really trying to how can we make it a much more idiomatic experience without causing any cold starts performance. The nice thing with this library is, since everything is, all the code is generated, there's no reflection going on. It's a really minimal impact that this library adds to any sort of cold start experiences, but still giving you that a much more concise API experience. And so, yeah, I think to sort of close up on all this, like, all of our .NET tooling is all open source. We had in this Amazon Lambda.NET repo out there. So this is where we put basically all of our .NET Lambda tooling. You can look into libraries, and you can see, this is where that library is right there that we've just been talking about. ASP.NET Core Service, all is out there, and really appreciate all the community's feedback on this one. This has been, like, in the years we've had this library, we've gotten more feedback on this repo than a lot of our other ones. A lot of great community help we've gotten on our .NET experience. I'm particularly excited too with .NET 6. The managed runtime, that runtime client, is now all open source. That's this guy right here. So now we can sort of have the community better help us drive even the experience at the lower level of the runtime client out there. So definitely would appreciate people's feedback. We have a design doc out there for that new library we're talking about. That's on issues. It's append up here for the annotations library out there. Check it out, the design doc, all the features that we want to add to it. It's not all in the library right now. And definitely give us ideas about what other things you'd like to get seen added to that library. So I think with that, we're getting near the end here.
Norm, that is super amazing. I'm blown away by the amount of extra work that's gone into .NET 6. I'm loving the integration with Visual Studio, with lots of other Lambda stuff happening in Node and Python and Java. I don't often see some of the super cool stuff your team is doing with the SDKs and making Lambda work so well with .NET. So yeah, thank you very much.
Yeah, thanks for having me.
No, pleasure. And yeah, just before we do say goodbye, if you are building any serverless applications and you want to wire together certain two things together, that could be AppSync or Lambda, or as we showed today, DynamoDB and Lambda. Look at the serverless patterns collection on serverlesslands.com. That is going to be super cool for wiring all these things together. And then up next week, I can't tell you, we've got some new things coming up, and we've actually got possibly a choice of 2. So we could be spoiled for choice. But yeah, slightly under wraps. I'd get into huge big trouble if I told you. But yeah, we're hoping hopefully some more cool serverless goodies coming your way, which we'll be able to talk about next week. Of course, everything on serverless at AWS, head to serverlessland.com. The patterns I talked about, we've got events coming up, learning paths, videos, blogs, everything to do with serverless on AWS. But Norm, I really want to say thank you so much for showing us a deep dive. You really are an expert with the SDK stuff, the tools, and the .NET Managed Runtime. That was fascinating, so I appreciate your time. If people want to get hold of you, what's the best way to do that? Twitter, Socket Norm?
Yep, I've got that weird name on Twitter.
That's
Socket
cool.
Norm is where I'm usually at for all this stuff. So
cool, excellent. Well, thank you so much. Send in your comments to norm4.net or other serverless things, send them on to me. And thank you very much for joining us. And we will catch you next week for the new episode of Serverless Office Hours. Thank you very much and enjoy the rest of your